Welcome back to Global Works TV. From the forests of Idaho to the precision mills of Switzerland, discover how raw timber becomes the lumber that built America. This is modern sawmilling at its finest, where century-old craftsmanship meets cutting-edge technology. There's something deeply American about the timber industry. For generations, our forests have provided the backbone of our nation's growth, from the log cabins of pioneers to the homes we build today. And nowhere is this legacy more alive than in the forests of Idaho, where the Idaho Forest Group operates one of the most sophisticated sawmill operations in North America. Let's take you on a journey that begins deep in the forests of the Idaho Panhandle, where the story of every board starts not with a machine, but with careful forest management. The trees being harvested today represent decades of growth, and the folks at Idaho Forest Group understand that what they're doing isn't just business. It's stewardship of a renewable resource that has sustained communities for over a century. And watch as these massive logging trucks navigate winding forest roads, each one carrying loads that would have taken weeks to transport in the days of horse-drawn wagons. These aren't just any trucks. They're purpose-built machines capable of hauling 40 to 50 tons of timber, equipped with specialized bunks and chains that secure logs ranging from 12 inches to over 4 feet in diameter. The drivers, many of whom learned this trade from their fathers and grandfathers, know every curve and grade of these mountain roads like the back of their hands. And as these trucks roll into the IFG Lewiston facility, we're looking at a sawmill that represents the pinnacle of modern lumber processing, yet one that honors traditions dating back to the early 1900s, when Lewiston was already a thriving timber town. Built in 2019, this state-of-the-art mill replaced facilities that had served the region for generations, but it brought something new to the table: efficiency and precision that our grandparents could only dream of. The first stop for these logs is the log yard, and this is where things get interesting. Now, back in the day, logs were sorted by hand, with experienced sawyers walking across timber decks, marking logs with chalk, and directing crews with hand signals. Today, at Lewiston, we're witnessing a ballet of hydraulics and automation. The log deck system here can handle over 200 million board feet of timber annually, and it does so with a sophistication that's remarkable to behold. Hiena's trucks enter the facility. They pass over computerized scales that record not just weight, but integrate that data with species identification and quality assessment. Each log is assigned a digital profile before it even touches the ground. The unloading process itself is poetry in motion. Hydraulic arms gently roll logs off the trucks onto a series of conveyors and chains that begin the sorting process. These aren't the jerky, clanking chains of old mills. Modern chain systems use variable speed controls that handle everything from slender poles to massive old-growth recovery logs with equal care. Here's something fascinating about log sorting that most people don't realize. The profitability of a sawmill operation is largely determined right here before a single cut is made. Idaho Forest Group's sorting system at Lewiston uses a combination of laser scanning, metal detection, and visual grading to categorize logs. The laser scanners, and we're talking about precision instruments that can measure a log's diameter to within a 1/16 of an inch, create a three-dimensional map of each piece of timber as it moves through the deck. NTHE facility primarily processes western white pine, ponderosa pine, Douglas fir, and western larch, species that have defined Northwestern timber production for over 100 years. Each species has its own characteristics, its own optimal uses, and its own processing requirements. Western white pine, for instance, is known as the wood of kings. It was once so valued that entire fortunes were built on its harvest. It's soft, straight-grained, and works beautifully, making it ideal for everything from molding to paneling. The computerized sorting system recognizes these differences and routes logs accordingly. NTHE metal detection system serves a critical purpose that harks back to forest history. Over the decades, loggers would sometimes mark boundary trees with nails or spikes. Occasionally, trees would grow around old fence wire or even remnants of historical logging equipment. These metal inclusions can destroy expensive saw blades and create dangerous situations. The metal detectors at Lewiston can identify a single nail buried deep in a 4-foot diameter log, allowing crews to either remove the log from production or route it to specialized processing equipment. Now, let's talk about what happens once these logs are sorted. They're moved to debarking, a process that has evolved dramatically over the years. The old ring debarkers, which use steel teeth to scrape bark away, have given way to modern pressure-fed drum debarkers and, in Lewiston's case, Rosser head debarkers. These fascinating machines use spinning arms with carbide-tipped bits that literally peel bark away in strips, adjusting automatically to the log's contour. The removed bark isn't wasted. It's collected and used for landscaping products or, increasingly, as biomass fuel to power the mill's operations. There's a beautiful circularity to this that speaks to modern sustainability practices. And after debarking, logs enter what's called the head rig, the primary sawing station, and this is where the 2019 upgrade at Lewiston really shines. The head rig they've installed is a testament to engineering innovation. It's a curve sawing system, which means it can adjust the cutting pattern in real time as the log moves through the blade. Here's why that matters. A tree doesn't grow perfectly straight. It has natural curves, tapers, and variations. Old-fashioned sawmills would cut straight through, wasting valuable wood. This modern head rig uses laser positioning to identify the optimal cutting pattern for each unique log, maximizing yield while minimizing waste. NTHE blade itself, and this is where things get technical in an interesting way, is a thin-kerf saw, meaning it removes less material with each cut. Traditional saws might have a kerf, the width of the cut, of a 1/4 inch or more. The thin-kerf saws at Lewiston cut at just over 1/8 of an inch. Over millions of board feet, that difference translates to thousands of additional finished boards. When you consider that ponderosa pine takes 60 to 150 years to reach harvest size, maximizing every log isn't just good business, it's respectful forestry, and as the primary cuts are made, we're watching lumber being born. The head rig produces what are called cants, squared-off timber pieces, and slabs, which are the rounded outer portions. But here's where the sophistication really shows. Nothing is wasted. Those slabs immediately head to a secondary breakdown line, where they're processed into boards, or if they're too small, into chips for pulp production or particle board manufacturing. NTHE cants move on to the gang saws, parallel blade systems that slice them into multiple boards in a single pass. Modern gang saws are marvels of precision. Each blade is individually tensioned and monitored by sensors that detect vibration, heat, and cutting performance. If a blade starts to dull or drift even slightly out of alignment, the system alerts operators immediately. This level of monitoring was impossible just 20 years ago. Operators relied on experience and intuition to know when equipment needed adjustment. After the gang saws, boards enter the edging and trimming process. Edgers remove the irregular edges from boards, creating the straight-edged lumber we're all familiar with. The trimmers cut boards to standard lengths, 8 feet, 10 feet, 12 feet, 16 feet, and so on. Both processes are now computer optimized. The edger scans each board and calculates the optimal edge cuts to produce the widest possible clear lumber. The trimmer identifies defects like knots or splits and makes cuts that either remove these defects or isolate them to lower-grade products. Here's something that connects us to sawmill history: the grading system. Even with all this automation, lumber grading still relies heavily on human expertise. Trained graders, many with decades of experience, visually inspect boards and assign grades based on criteria established by organizations like the Western Wood Products Association. These grades, select, common, construction, standard, utility, have been used for over a century, creating a common language for lumber quality that spans generations. A grader from 1950 and a grader today would understand each other perfectly. NTHE graded lumber moves to the sorting system, an automated wonder that would have seemed like pure science fiction to old-time sawyers. Boards travel on chain conveyors, and pneumatic kickers, air-powered arms, divert each board to the appropriate bin based on its grade, species, and dimensions. The coordination required is remarkable. The system processes hundreds of boards per minute, each one going to exactly the right destination. NBUT were not done yet. The lumber now enters the drying kilns, and this is where science meets art. Kiln drying is essential because fresh-cut lumber, called green lumber, contains so much moisture that it would warp, crack, or rot if used immediately. The kilns at Lewiston are temperature and humidity-controlled chambers that gradually reduce the moisture content from perhaps 40% or 50% down to around 15% or 19%, depending on the intended use. Modern kiln control systems are sophisticated. They don't just blast lumber with heat, they follow carefully programmed schedules that adjust temperature and humidity over days or even weeks, depending on the species and thickness. Douglas fir, being denser, requires different treatment than white pine. The kilns monitor conditions constantly and experienced kiln operators, yes, there's still very much a human element here, make adjustments based on the specific characteristics of each load. And after drying, the lumber goes through planing, the final surfacing process that creates smooth, uniform boards. The planers at Lewiston can process lumber at speeds exceeding 1,000 feet per minute, with cutting heads that have dozens of precision ground knives. These machines remove saw marks and smooth rough surfaces, but they do more than that. They also bring boards to exact dimensional specifications. What we call a 2x4 is actually 1.5 inches by 3.5 inches, because the planing process removes material from the rough cut dimensions. The final step is packaging and shipping. Lumber is bundled according to grade and dimensions, wrapped with steel banding that can withstand cross-country shipping, and loaded onto trucks or rail cars. The facility ships lumber across the United States and internationally, continuing a tradition that saw Idaho lumber build cities from San Francisco to Tokyo in the decades after World War II. What makes the IFG Lewiston facility special isn't just its technology, it's how that technology serves a sustainable operation. The mill uses virtually every part of every tree. Sawdust becomes pellets for heating. Chips become paper. Bark becomes mulch or fuel. Even the wood waste from planing becomes particle board or fiber board. This integrated approach reflects a modern understanding that responsible timber harvesting means treating every tree as the precious, decades-long natural creation that it is. Standing in this facility, watching logs transform into lumber, you're witnessing a process that connects us to every generation of American builders. The technology is new, but the purpose is timeless, taking nature's bounty and transforming it into the material that builds our lives. Now let's cross the Atlantic to Switzerland, where precision isn't just a watchmaking tradition, it's how they approach everything, including timber processing. August Breweiler AG represents a different philosophy of lumber production, one that emphasizes artisanal quality even while embracing modern technology. NTHE forests of Switzerland are different from Idaho's vast timber stands. Here, forestry is measured and deliberate, with trees harvested as part of centuries-old management practices that date back to medieval times. When you see timber coming out of Swiss forests, you're looking at trees that may have been planted by someone's great-grandfather, growing in forests that have been managed by the same communities for generations. There's a weight of responsibility in that tradition. NTHE harvesting operation begins much like in Idaho, but with a distinctly European character. The logging crews work with precision that reflects the Swiss mindset. Every cut carefully planned, every tree felled with consideration not just for immediate harvest, but for the health of the forest decades from now. The timber trucks making their way to the August Breweiler facility carry loads of spruce, fir, and pine, species that thrive in alpine conditions and produce lumber with characteristics prized throughout Europe. When these trucks arrive at the Breweiler facility, you immediately notice something different from large industrial operations. This is a mid-sized sawmill, but what it lacks in scale, it makes up for in specialization. The company has built its reputation on producing premium-grade lumber, the kind that goes into fine construction, furniture, and specialty applications where quality matters more than volume. NTHE log yard here is organized with almost military precision. Logs are sorted not just by species and size, but by source forest, age, and even the season they were cut. This level of detail matters because Breweiler's customers demand consistency and quality that requires understanding every variable that affects wood characteristics. Winter-cut spruce, for instance, has different properties than summer-cut timber. The tree's metabolism changes with seasons, affecting grain density and resin content. NTHE debarking process at Breweiler uses a Rosserhead system similar to Idaho's, but scaled appropriately for their operation. What's interesting here is the attention paid to preserving the wood quality beneath the bark. Alpine spruce, growing slowly in harsh conditions, develops tight grain patterns that are highly valued. The debarking equipment is calibrated to remove bark without scarring the valuable wood underneath, a tolerance measured in millimeters. Moving to the primary breakdown, Breweiler uses a band sawmill, a different approach from the circular saws common in North American operations. Bandsaw mills use a continuous loop blade that allows for incredibly precise cuts with minimal kerf. The bandsaw at this facility is a marvel of Swiss engineering, with blade guides that maintain accuracy within a few hundredths of an inch, even through knots and grain variations. For a furniture maker receiving lumber from Breweiler, this precision means less waste and more usable wood in every board. NTHE sawing strategy here reflects European sensibilities about resource use. Each log is analyzed. Sometimes the operator will walk around it, examining grain patterns and natural features, before committing to a cutting pattern. This isn't mass production, it's thoughtful processing. A particularly beautiful section of figure grain might be cut differently to showcase that natural artwork. A log with tight, even grain might be reserved for cutting into specialty dimensions. And after primary sawing, the lumber enters a sorting and grading process that combines technology with experienced human judgment. The grading standards in Europe differ from American systems, but the principle is the same, matching wood quality to end use. What's remarkable at Breweiler is how much individual attention each piece receives. Boards that show promise for high-grade applications are set aside for special handling. The edging and trimming operations here use equipment that's precise but not rushed. The emphasis is on maximizing value, not just volume. An American sawmill might process 200 boards per minute through its trimmer. Breweiler's system runs at perhaps a third of that speed, but the yield of premium lumber is extraordinarily high. This reflects a different economic calculation. When you're producing for markets that value quality and pay accordingly, speed becomes secondary to excellence. NTHE drying process at Breweiler deserves special attention. They use both conventional kilns and air drying, depending on the intended use of the lumber. For certain high-value products, lumber is air-dried for months in covered sheds before finishing in kilns. This traditional method, increasingly rare in modern operations, produces lumber with characteristics that kilns alone can't match. The slow moisture loss allows the wood to relieve internal stresses naturally, resulting in more stable finished products. NTHE kiln technology itself incorporates innovations specific to European hardwoods and softwoods. Alpine spruce requires careful drying to prevent the checking and splitting that can occur when resinous softwoods dry too quickly. The kiln schedules used here have been refined over decades, balancing efficiency with quality in ways that reflect both science and experience. And final processing includes planing and finishing operations that prepare lumber for demanding applications. The planers here produce surfaces that are remarkably smooth, with finish quality that requires minimal additional sanding. For customers producing visible woodwork, furniture, interior trim, flooring, this level of finish quality is essential and valued. What makes August Breweiler AG representative of a broader European approach is their integration of traditional craftsmanship values with modern capability. The facility uses computer optimization and automated handling, but never loses sight of the fact that they're working with natural material, each piece unique, each requiring understanding and respect. It's a philosophy that connects contemporary Swiss timber processing to guild traditions going back centuries. In both operations, Idaho's high-volume efficiency and Switzerland's precision craftsmanship, we see lumber processing that honors both the resource and the craft, using technology to serve timeless purposes.